Welcome back, guys. In this video, we start to learn how to use it and then compare the different deep learning frameworks. Okay, let's get quick of it. When we build models, we should design its scratch, such as input nodes, what types of data do we want, when data enter the models, how to use these data. Also, we should define the operations and when we train our models, how to optimize these models, how to evaluate a model. Let's see a very simple example. The MNIST dataset. A MNIST dataset is very easier for deep learning learners and for beginners. And a MNIST is an interest level in experiment in deep learning. It equals to hello world in programming. Since the MNIST dataset is samples data for TensorFlow, we don't have to download it. Let's take a look at this dataset. This is one of the datasets. It's 28 multiples 28 pixels, so we can present it into the two decimal intermatrix of this same size like that. Use this image can represent like these two dimensionals, the interest matrix. And we also can translate the matrix into a one-dimensional vector. So the size of the vector is 28 multiplied 28 equals 784. Then we combine 15,000 pictures together, and then we can get 15,000 multiplied 784 tensor. This is the two-dimensional matrix. The first dimensional represents the index of the picture, and the second dimensional represents the index of the pixel in pictures. When we import the data into our models, we do data normalization first and divide each value of pixels by the 255. So the pixel value in the tensor is between 0 and 1. Now let's see the labels of the dataset. So it's 55,010 matrix. Like just before, as we introduced the dataset, the first dimensional represents the index of label, and the second dimensional represents the numbers. And here I introduced a new concept, and the one hot encoding. In these samples, the length of the vector is 10, and we set none of the elements as 0. So and the only one except to the 1. And then the index of the 1 represents the number of the labels. So this is the 1. Is this sample, and this is the 1, and this the 1, and the white block is 0. So we can translate the numbers into have the two numbers, two values, just 1 and 0. Use their different sequences, meaning the different values. Okay, after introducing the data set, and we should know how to define the input nodes. We can define it by the placeholders, by the direct string types, and directly defined. Direct defined is not is seldomly we used, and the first method, and by the placeholder, we use it frequently. In our experiment, as for the input images are
15,784 matrix. So we can create a placeholder x of the non 784 for training data, and a placeholder y of the nonce and 10 for training labels. And then we used the feed mathematic to input image and labels. Next, we will introduce how to set our parameters. Just like we learned before, when we build a model, we should define some learning parameters. Then we can use the training data to update these parameters and get a good model. And Tensorflow has the following method to define the training parameters: direct definition and by the dictionaries. And the learning parameters encode weight values and bias value. In Tensorflow, learning parameters are defined by variables, and variables represent the modifiable tensor, so it can be modified during training procedure, and it is defined in Tensorflow graph. Next, the core step is defining the operation. In the defining operation, it's a core process to build a models. That means the fitting effector, and we need to define the three types of operations, defining the forward propagation models, and define the loss function. Also, we should define the backpropagation script. The first operation determines the model how to use the data to get the result, and the second operation means the define the loss function as to measure the distance between the result and the real labels. And the third operation determines the models how to modify our models. Now let's creating a model. When we do the multi-categories task, and software regressions is often used, the softmax models can assign the probability for each pixel to different objects. Look at the picture. The blue represents the negative weight, and the red represents the positive weight. Then we can sum these weights up, and so we can get the result. As we all know, all things that are not perfect, and there are noises in our training dataset, so we need to add the extra bias. Then we can get the formula below like that, and add our bias. And this WI encodes the weight, and this is our data vectors, and the I is the G indicates the pixel index of the given image. And then we use the softmax function to convert the applications to the probabilities of the Y, and to transfer our data, use the softmax this function. Here we should show the regressing models. When we input our vectors, we set different weights and bias for each element in the input vector. Then we calculate the result and input it into the softmax function, and then we will get the probability of each categories, like the workflows of the regression models runs. And this is our input data, and we should add the weights and add the bias, and each will get biased, and then we use the software thing to transfer the values into the probabilities, and we get the result. In actual calculation, the models usually use the matrix calculation. If you are familiar with linear algebra, you can easily understand it. This is a vector, and this is the matrix, and you use this matrix, the weight matrix, and to multiples the vector and add the bias. This linear algebra, that's calculations processing. It can be written in the more compact way, like this, the formula and the software and the weight, use the weight and add our bias. Now we began to optimize the model and make it perform better. In this process, we send the error back alone and reserve the direction of the forward propagation, and involves the L1 and L2 regularization, improved adjustment, learning rate, adaptations, randoms, gradient descent algorithms. And when we build models, we need to create a huge number of the weights and bias. To prevent zero gradient and break symmetries, we should add a small amount of noise. Consider to avoid repeated initializing driving model creation, and we defined two functions for initializations, and these functions like that, and the TF the point, the triplicate normal, and TF the constant, and to also this is just for the weight bias, and this for the bias, and for the initialization. The model is already built. We need to define the indicator to evaluate this model is good or not. And this is called the loss function. It minimizes the difference between the prediction and the real result. Our goal is to minimize the loss function. In this experiment, our loss function is cross entropy, and we used this cross injection function as a loss function. And we used the gradient descent algorithm to minimize the cross entropy at a learning rate of the 0.01. And the TensorFlow simply moves each variables little by little in a direction that keeps the cost down. And here we start training the model. Let the model circles training for 1,000 times. After we training the models, we should test it and observe whether it performs well or not. In the previous course, we mentioned one-hot encodings, and we can use the TF, the pointer X algorithm max to get the index of the 1 since it's larger than 0. And we used the TF pointer equal to test whether the prediction is the same as the label. For evaluate our models, and we can add a model evaluation to the computing graph, then call the model evaluations after model training. The model evaluation mainly involves the following indicators: average accuracy and identification times and loss decrease. Driving model training and model evaluation helps gain insights into the model algorithms and provides the prompt information to the debug and improve or modify the whole models. After training the model, the performance of the model needs to be evaluated quantitatively. Now we can save the models, create a saver and pass, and then call the same command to save the parameter in the setting. If we want to use the trained models, replace the nodes of the loss value with the output nodes. This is similar to what has been done in the model testing. If we save the node to the disk, now we want to use it, we should read the model first and add images to the models for prediction, so we can get the labels. We can see from the picture when we train our models about 1,000 times, and the accuracy will be 0.9044, and when we train our models about 9,000 times, accuracy is the 0.949898. After we training our models the 10,000 times, and the test accuracy is the 0.9475. The test accuracy is different from the validation accuracy. It's more focused on the examines the generation capabilities. We can also add 2 images to the model and get the predict results. These don't change our models, and all operations are performed in the new settings. Okay, up to now the TensorFlow part is finished, and let's talk about other deep learning frameworks. Theano is a deep learning and a machine learning framework. It has been developed about for more than 10 years. It is the pricing library that learns the defined, optimized, and elevate mathematical expressions involving the multi-decimal arrays efficiently. It has a better scalability, and also Touch also has a good scalability. But some interfaces are not comprehensive. It needs the logit, and this logit uses the lowest language, so it lacks the universality. And Keras is a combination of the Theano's framework and the TensorFlow float int, and it has a good transportability. And deep learning 4G is writing in Java and Solar. It is applied to deep learning software on Hadoop and Spark systems. And Caffe is a powerful image classification frameworks. It is easiest to test and evaluate performance. And MXNet is the deep learning library with good transferability and scalability. It provides some features of Touch, Theano, and Caffe. It is currently one of the most popular frameworks. And CNTK is a deep learning toolkit developed by the Microsoftware and has the faster speed and custom neural networks describes in language, and is called Brain Script. It is not as major as TensorFlow, but inherently cooperates with the Visual Studio. From this table, we can compare these frameworks and to know some details about these frameworks, such as the core, which language write their core, and which framework support CPU, support GPU, support even macros, and more detailed information in the table. We can see very clearly. This table shows the advantage and disadvantage of these frameworks. Although TensorFlow is difficult to comprehend because its core is written by C++, and but the TensorFlow is very popular for engineers because there are many materials in GitHub, in blogs that will help us to learn it. And also TensorFlow is used widely, so we should learn it and to do our deep learning project. Okay, they finished this part.
Okay, till now we have finished the TensorFlow basics. This chapter described the concepts, characteristics, basics knowledges, and the common usually modules of TensorFlow. They introduced how to set up the development environment and create TensorFlow programs. It also describes the basics development steps using TensorFlow and the internal mechanisms of TensorFlow. In the end, we introduced the other deep learning frameworks. After finished it, that can help us to build our own project better. If you aren't familiar with this part, I suggest you practice it frequently and master some common basics modules. In next video, we will learn the important part, deep learnings, and I hope to see you in the next video. Thank you for your watching. Bye.